Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en zoals altijd is mijn metgezel...
Lekker dan. Ik ben Jan Stomphorst, Solutions Architect ACC ICT. Welkom Ronald.
Ja, welkom Jan. Jij hebt dit je talk achter de rug, hè?
Nou ja,
Huh?
we moeten even...
Zweet staat nog op zijn voorhoofd.
I'm still sweating for my talk. But yeah, let's switch over
Switch
English.
quick. Yeah. We have two guests, Brian Stevens and Robert Shaw. And can you please introduce yourselves? And I will start with Brian.
Yeah, sure. Thanks for having us. I'm Brian. Yeah, I've been the last 5 years been at a company called NeuralMagic, focused on inference. And just about a year ago, we were acquired by Red Hat. So now looking after AI the best I can at Red Hat with a title called the AI CTO, whatever that means.
And what's your background? How did you get started if you turn on the Wayback Machine?
I ran engineering for Red Hat from 01 to 13, and so built the first version of Enterprise Linux because I came out of the Unix world before that. And then I left there for 5 years, went to Google Cloud. First thing I did was open source Kubernetes and create the CNCF as part of Google because they needed to contribute more to open source and didn't know there could be this CNCF. And then after Google for 5 years, building cloud for a company that didn't care about enterprise as a user base for cloud. And so kind of did that pivot. We all know security capabilities you need and everything else you need for enterprise consumption. So we built all that out and got Google Cloud on its way. And then moved back to the East Coast, and then made a mistake of meeting a professor from MIT that had started a company focused on inference called NeuralMagic, and fell in love with them and fell in love with the learning, around AI. And so yeah, that's it.
Okay. And normally his follow-up question is, what was your first distribution in Linux?
That's creating Fedora.
First Kubernetes.
That's also one. Yeah.
That's also.
Yeah.
You start with
The
zero.
first Kubernetes was, so I was at Red Hat when Google approached us to launch Kubernetes, right, to public, but they wouldn't let us be a contributor. So imagine that world.
Yeah.
And so no, so we're not going to be a launch partner unless you give us one committer seat.
Right.
And so it took them 2 months, and then they gave us one committer seat. And so we put a really great OpenShift developer on that named Clayton Coleman. And then after that, I think it was 6 months after that, I went to Google and open sourced the whole bit. Right. So I think it was like the first version of Kubernetes, perhaps.
Was it never the intention to open source that?
It was open source. So they had invited Red Hat to be the launch partner of open source, but there was only Google was going to be the developer of it. So kind of how they did TensorFlow. But yeah, this is the way back in 2013. And then when I got to Google, I mean, after being at Red Hat for 13, 14 years, right, we understand, like it's about shared source, right, and collaboration and everything, the ecosystem. Mm-hmm. And so when I got to Google, one of the questions I had is like, why aren't we using open source, right, like to define us, to be honest, right? Because they used a lot of open source. They just weren't contributing back to the community. So one of the thing around Kubernetes, a very important project, and they'd already made all the mistakes of how you do orchestration with the Borg.
Yeah, exactly.
So this time it was like a rewrite of how you do it right. So like really important thing. I'm like, but it should be everybody's. And then part of it was there was a lot of orchestration systems back then in 2014 vying for, there's Swarm and others, and tried to convince Docker to embrace Kubernetes.
Yeah, Docker Swarms.
And wouldn't spend a lot of time with Solomon and others and embrace it, take it. We made all mistakes and it'll be great for the world because you'll bring it everywhere.
Yeah.
And the answer is no. So then it was a call to Jim Zemlin to let's create this thing. It won't be as big as OpenStack, but it's pretty important. It's called Kubernetes. And so then we created the CNCF, but never, like I said, never what I expected.
Yeah.
You know what I mean? Like
what? 13,000 people here.
Yeah, it's crazy. This is my first KubeCon.
Oh, yeah?
Yeah.
Your first KubeCon.
I know. How creative. It's my first one. That's embarrassing. That's the thing you don't say on a recorded.
No, and it's so massively big here.
Yeah. but it's vibrant still, though. You know what I mean? Like a lot of things kind of wane, and like it's really energetic.
Yeah,
You know, downstairs.
Yeah. Upstairs it's
Upstairs?
it's quiet.
No,
Upstairs, yeah, okay.
No,
But let's switch to we have another guest.
yeah,
Right?
yeah.
Sorry, Robert. Can you please also introduce
it's
yourself?
great.
Yeah. That's a tough act to follow. But yeah, I'm Rob. So I worked with Brian at Neural Magic. I led engineering for Neural Magic. And there we, got involved with vLLM, which is the, leading open source inference runtime for LLMs. So been working on vLLM, for over, 2.5 years now. I'm one of the co-leads of the project. So working with the whole community to bring all the new models in, work with all the accelerator vendors to bring, new hardware into the platform. And then when we got acquired by Red Hat, we created the LMD project. So I'm one of the maintainers of LMD. And, this is kind of the next thing we've been sort of focused on is taking vLLM distributed. How does it integrate with Kubernetes and build that kind of next frontier of inference optimization? So I work on all of these things at Red Hat, up and down the inference
Different kind of
stack.
hats also.
Yeah, different kinds of hats. Work a lot with customers and trying to help them to deploy these things, and then in all of the communities to build the future of open source inference.
Okay.
And he undersells himself because he's one of the smartest people I've ever met. So he's been like a real he was a real partner, like in knowledge, not just like a developer, like strategy and everything else. So he's amazing.
So what piqued your interest in going to in the IT? If your background a little bit.
Yeah, I mean, before it's funny. Before I got into tech, I was actually on the dark side, working in investing. But actually, I worked for a private equity fund, actually doing software investing, and I used to sort of focus on infrastructure software investing, and a lot of the types of businesses we were looking at had open source business models attached to them. So I was always really kind of fascinated by the how the community strategy, the open source strategy, the partner strategy, the technology strategy, all of these things work together to try to create a business model around these really important kind of foundational projects. So I'd been looking at a lot of that from a kind of business model side, trying to understand different companies' business models and around these open technologies. And then I kind of got tired of being on the sideline and wanted to get really into the action. And so I had met Brian through some work I had been doing in my previous job, and I got into AI in 2022. I didn't know anything about large language models at that time, and it turned out that 6 months later, ChatGPT launched, and obviously all of this craziness has happened since then. And so it's been a real roller coaster, growing up with this whole ecosystem, and it's been really, really fun and showing no signs of slowing down. So it's it's good.
Okay, great.
So and I'm interested. What is the best model for an open source company to make money?
Yeah, that's
The $1 million question.
Yeah,
or-
no,
And what sons aren't?
that's a great question. So I mean, I think sitting on the outside looking at these companies without living it kind of day to day, I had a different perspective about what Red Hat did. When I was working as an investor. And, Red Hat kind of had the original open source business model, which is this subscription. It's about the stability, lifecycle management. And honestly, there's this new term that a lot of companies talk about called forward deployed engineers, which is a funny term, but I think Red Hat has the biggest group of forward deployed engineers of almost any company, out there, which is people that can work with customers to make them successful with the technologies. I think you guys understand this really, really well, but, Red Hat is a people, processes, product company where, it's not just about the software, it's about all of the organizational capability to work with customers on long-lasting architectures that, stand the test of time. And so that's one business model. I think Red Hat has been relatively unique in, commercializing that at a really, really, really big scale. And there's been some other businesses that have done that around different types of technology and have carved out.
But if you have an open source application like Trivy, just they had just a big security problem, but like Trivy or something else, because Red Hat is unique. Yeah, we know Red Hat has now IBM behind it and has some momentum and has a well-known name. But if you start up and you don't have a well-known name. How do you monetize, or how do you?
Yeah, I mean, but what's kind of happened over the course of the past, kind of decade is cloud has created a really actually great way to, commercialize open source, which is, a lot of the companies that have been successful over the course of the past decade have built these kind of managed businesses where they're offering a service based on the open source, software. Examples are companies like Databricks or, MongoDB, for instance, where, and honestly, every single cloud that you can think of, AWS, GCP, are all offering, managed versions of all sorts of open source technologies. And, it's actually pretty rare to even find, any proprietary, infrastructure software powering major applications. So I think that this has been a really, interesting model over the course of the past decade. One of the things Brian and I we were actually talking about this last night is, with AI, and we've kind of seen this like token consumption model that's gotten created. I'm actually interested to sort of see if there's new business models that can be created. And I don't know what that is yet, but, cloud was an amazing trend for making IT easier to consume, but it also created this new business model that aligned the cost with the value, with these kind of on-demand pricing and, kind of elastic sort of spending. And it created all these new business models where you could monetize the delivery of the service and still have the open technology that the industry could kind of standardize on. I'm searching for in some ways of like what new kind of business models can also be created around AI. I don't have an answer to that question, but I think it's I think it's something that I think there's like potential for something different to emerge that whether it's charging for jobs to be done as opposed to per token. You know what I mean? Like I think there's some interesting things that I hope the ecosystem explores. I don't know if you have anything else.
Told you he was smart.
So you were talking about inference runtime. Could you explain to our listeners what do you mean by that?
Sure. So at the end of the day, like when you talk to a LLM service, you send a prompt to the model and then you get back text. So at the end, to make a service like that, you need kind of three things. One is a model. Second is an accelerator, typically. And there's a piece of software which runs that model on the accelerator. This is what an inference runtime is. The model at the end of the day is kind of an abstract graph. It's a series of matrix multiplications with parameters attached to them. And this is an abstract, kind of concept. It's a binary blob that has the weights, and it's a PyTorch graph that says, do this multiplication, do this attention operation, yada, yada, yada. And so the inference runtime's job is to take that abstract graph and run that as efficiently as possible on the GPU. And this is a really actually hard challenge for a few reasons. One is you have these massively powerful GPUs, and you want to squeeze as much performance as possible out of them.
Yeah.
So there's all this kind of like low-level CUDA programming to make sure the operations of the model are really, really, really efficient. But in addition to this, an LLM server is kind of like a database system. You have multiple concurrent requests. All of these are going to be sharing the resources of the machine, the memory for the KV cache, which request is running at any given time. So there's all of this sort of like state and concurrency management that needs to happen in the inference server to, make all of this work, to be able to, basically interleave different transactions happening at the same time. And so that's what the inference server does. It's half kind of like operating system scheduler type code of like memory management and like request management, and half kind of like high performance CUDA code to make the operations. And, that's effectively what, something like vLLM is. And it's a really, really important piece of infrastructure because there's a huge ecosystem, right? We have tons and tons and tons of different models, Mistral and GBDOSS and DeepSeek and, Llama. And there's an insane pace of all these new models coming out. And then similarly, we have insane pace of new hardware. Obviously, Nvidia is
expensive hardware.
Yeah, expensive. But, we have Nvidia, within NVIDIA, there's tons of different subvariants. There's new architectures coming out. We have AMD, we have Google TPUs. And so the runtime's job is to really be that Rosetta Stone technology that's taking all of these different models, all of these different accelerators, and kind of providing this, single system that someone can deploy across it and get really, really good performance to kind of build these inference services that, are kind of powering AI applications today.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
Have you looked into in BitNet? That's more like CPU based, right?
Yeah, so BitNet is an example of an inference runtime that's targeted at a specific type of model. So, BitNet is, runs these kind of 1.5 bit parameter models that are extremely aggressively quantized. A lot of those, I wouldn't say that BitNet is a practical deployment right now because, typically, you don't see very many LLMs that are quantized to that particular level. Right. But in vLLM and all modern kind of inference runtimes, there's lots and lots of features to take advantage of low precision.
Exactly.
And so, on the Blackwell Nvidia chips or the MI 350s from AMD, there's kind of 4-bit precision. So the models are typically trained in 16-bit precision, which means there's kind of 2 bytes per parameter. But the modern accelerators have kind of these 4-bit operations, which are 4 times faster and consume, 1/4 of the amount of memory. So there's a lot of kind of actually algorithmic approaches for how to kind of take the models and convert them to these lower bit precisions that can then give you speed ups. And in the vLLM community, and honestly from our heritage at Neural Magic, we've invested in lots of these kind of frameworks around the inference runtime. So we have a project called LLM Compressor, which is sort of part of the vLLM community, which implements all these algorithms for kind of applying these model optimizations. But I think you're hitting on something which is these GPUs are really expensive. These models are really, really big. So performance is super, 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 super important. So, runtimes like vLLM that squeeze as much performance as possible, algorithmic techniques like quantization or speculative decoding, with our libraries like LLM Compressor and speculators, which help to kind of make the models themselves smaller and therefore more efficient. And I'm sure we'll get to it, the distributed layer. All of these things are super, super, super important to, running a high performance inference system because, performance directly translates to costs, in these systems. And, the models are big, the accelerators are expensive. And so, all of these performance optimizations are of the utmost importance whenever you're thinking about running an LLM system.
Yeah, and it's easy to, when you're applying some of these techniques like quantization, it's easy to collapse the capability of the model. Call it performance, but what we mean is the accuracy and the quality.
Yeah.
So that's why a lot in the past have stayed away from, you were talking about getting to 1.5 bits, but they stayed away from even 8 bits, 4 bits, because it's not as blind as just compressing. It's how you do it, the scales you do it at, which parts of the model, activations, and you're doing it in such a way that we would do a lot of research. Our biggest use of GPUs before was to actually run workloads for how do you compress these models, but always preserving 99% plus of the accuracy. So that was kind of the model, because otherwise you'd lose kind of enterprise trust and capability because it's easy to kind of do it at 95%, and then all of a sudden you can compress more of the model, but then even that, 95% could be wrong 100% of the time.
Exactly.
And so the design center for this LM compressor package was a ton of research, that Neural Magic Red Hat do, and then codifying that into an open source toolkit that when they apply the compression techniques, and usually to match the type of hardware you're running on, newer hardware has different compression capabilities for running it, then you kind of match it. So you'll build a version of that GPT OS, that has different compressions applied to it based on H100s, newer GPUs, and then you apply it, but always keeping that, 99% plus accuracy. And so contributing that to open source, what's amazing is now you're seeing the big frontier models actually not just contribute to that LLM compressor suite, but actually use that when they release their new frontier models. So it's just one thing. Like you get what often, Rob, like you can get a 2x lift, on hardware efficiency by running a compressed model. So think about like that 2x means to the efficiency of these really millions of dollars of accelerators.
Yeah.
So compression is kind of a thing. And then vLLM participates with that. It understands when a model's been compressed and it orchestrates the accelerators in a different way with different kernels.
Yeah, you can zip everything, but if you cannot understand what's in the zip file.
Yeah, exactly. Yeah, that's a better way of saying it. You can never unzip.
Is it smarter to run one big LLM or one big model or 15 or 15?
You always want to match the use
Small
case.
ones.
You always want to match. So like whatever we said is, because I think the industry was like always trying to start with small models.
Yeah.
And it's almost like starting with one arm behind your back. You know what I mean? To solve a problem.
There was really a thing that we have a small model behind a small model or behind a small model. And those small models were really specific in their cause.
Yeah.
They checked each other. Too.
Yeah.
They checked also each other, and then there was it was a real cascade of that.
But you're probably not going to do your code development on one of those today, we'd agree, right? Like, because it's kind of like the bigger models that all. So some of the best ways to start with the biggest, most capable model possible to solve a problem set, and then reduce down from there. Because the first part is, did I solve the use case, right, that I'm trying to achieve?
Yeah.
And then you can look for optimization techniques. It might be quantization of that larger model. It might be going to a smaller model. But first, like, solve the problem domain, whatever that might be, for the organization. But sometimes, they find like starting with small models, we've seen that you can spend a year of investment into a small model trying to solve a domain case and never achieve it. And so the art of the possible is usually determined on the biggest models possible. And then all of a sudden you're like, well, yeah, but to run it at scale is too expensive, or it doesn't fit on this form factor. And then you go and you try to do techniques.
But foremost, bigger is better.
You're seeing all the breakthroughs happening around big models. But I'm a big believer that like then you're going to get to domain level, like sub-agents, that are based on domain level models that are trained on supply chain capability or et cetera. So we see it all fitting together.
Isn't it a little bit the same as what you do with the image processing with the LoRa models also? LoRa, right?
Yeah.
The one specific LoRa is better in this kind of image and the other one is better in this kind of image. But they look at the big...
Because they're fine-tuned in different ways. They're fine-tuned in different ways. Yep.
Layer between them.
Yep.
We've got a podcast about that. But
Really?
Episode.
And like the other thing too is, I think, like one of the model families like I'm most excited about is like Nvidia's Nemotron models. Like, I don't know if you guys were at
Not
GTC,
yet,
but they Nvidia is, investing very, very heavily into these open weight models, which are, the stuff obviously that we're running at Red Hat. And, one of the things that's cool about Nemotron is like they offer models in various sizes. So they have like a 30 billion parameter one, they have a 120 billion parameter one, and they, going to have a bigger one, kind of after that. And so, and then, other model families like Qwen, for instance, have kind of a similar dynamic where they offer like models in all of these different, kind of ranges. And so, the pattern Brian's, kind of talking about of like, deploy the most sophisticated one, make sure the workload works on that. And then as that workload gets to scale and it starts becoming expensive, you can start looking at either like customizing the smaller ones or, just moving them over if you're able to make it kind of work with the standard kind of prompt engineering and harness techniques. So yeah, that's it's just kind of like all these open models are coming in various sizes, and that provides you the ability to kind of switch between them as needed, depending on your cost and your,
because we had a lot of legacy work because the foundation of the startup that Rob was talking about, the Neural Magic, was focused on CPU-based inference. So let's skip the whole accelerator paradigm. Let's bring AI to, everywhere, right? Which means x86 and ARM. And then that was working reasonably well until like large language models came out. And then all of a sudden the processing power that large language models needed, because we were handing it so much data, so much compute content. You weren't doing that before with transformers. Maybe it's a document to summarize but we saw like an explosion we built the whole serving stack for CPUs for LLMs, and you just found they couldn't really handle the compute bound part of the problem, which is all the input.
But it is still a big market for the
We
smaller
agree.
ones.
No, we
And
agree.
because I was listening to the podcast, you've got the new phone network, 6G.
Yep.
And that's going to implement an AI in the network to beam your connection. So he can predict where you're going to walk or where your phone is going.
Yep.
So
It's both. No, it's definitely both. It's just that we wanted to come right when we pivoted from CPUs to GPUs is because when LMs first came out, people couldn't run them on GPUs. So they were sizing the number of GPUs they needed, not based on the core capacity of the GPUs, but by the amount of memory the GPU had. And so that was why we pivoted. It was like they were using 4 A100, H100s to run one model. Like insane, right? And so we dove in, with vLLM and other tools to create maximal efficiency on GPUs. But part of the vLLM project, Rob, is taking on adding CPU support to the same inference engine. So then all of a sudden you can have, one user experience for models, right? Choice of accelerators, but also, Intel's been driving a lot of the, x86 capability. We've been, at Red Hat have been doing like, all the management pull request reviews of the x86. So we expect vLLM very much to support robustly CPUs. It's just that often you come in with a CPU-based infrastructure to do inference, and then people compare you against, are you as good as the biggest accelerator? So it's kind of a hard, they want it, but it's...
we have to go to final questions.
And one question, I think, because there's also a thing happening, and it's more of like personal. You see AI everywhere, right? And the term AI slop is also getting a little bit air traction now, and especially since the Nvidia presentation about DLS5, that they make games like the graphic. With AI, they overhaul the graphics, and it almost seems photorealistic, and the artistic view of the creator is gone because everything is AI.
Yeah.
Well, how do we prevent, like you say, AI will be everywhere, but we must prevent that the moment of the situation that people say, yeah, well, I'm done with this.
Yeah.
I can see myself also. Sometimes I use Gemini. I think you're getting stupider by the day.
Yeah, I'm contrarian to it myself. I still am a big believer of human in the loop. Like it's an amazing tool. I mean, there's going to be places for full autonomy, no doubt, right? But I'm a big believer of the value of the human in the loop and then using the best tools for the job, right? And there's some really great tools that have been added, right, to the portfolio tools that we use. Yeah. And one of them is AI. And if you're not using it, you're kind of ignoring a new tool that's emerging, but it doesn't mean that it's a panacea. But so I just think like the most productive people are the ones that are going to be, expanding their repertoire of tooling, whatever role you're in, right? Whatever role you're in with AI.
Your turn.
Yeah. Okay. So our final question is always, how do you see the future of Kubernetes evolving the coming years? So, a question for both of you, but Rob, you can start answering if you have like an idea.
Yeah, I think someone was talking about this in the keynote today. Like, inference has the chance to be the single biggest workload ever. Like, I think that it's sometimes hard to understate the scale of the build out that's happening, in the ecosystem. And so, if Kubernetes is going to continue to thrive, it needs to be the best possible place to run, inference at scale, inference and agents at scale. And so I think this is a big part of like why we, contributed LMD to the CNCF and why there's just such excitement about making these, kind of accelerator and inference workloads, such a big part of, the focus of, CNCF for the next, period of time. And so that's really where I see the future and where like the focus should be is on, making these inference workloads, which are accelerator based and there's a lot of networking focus, making this all work really, really well on top of Kubernetes and building the platform where the agents that are going to consume this inference can run, really securely and operators can have control over how they're, managing access. So I think this inference agents theme is going to be really here to stay, over the long haul.
Cool. Yeah. Well said.
Yeah. Anything to add?
Yeah, no, I totally agree. And I think like we weren't sure that was going to be possible. Like, so the view was like, if to run AI at scale was going to be a whole nother stack, like what's that world look like? Because we kind of
Kubernetes
feared,
was not designed for that.
but we 100%, right? And we kind of feared like every accelerator is going to build their own stack. A little bit of that's happening. Every accelerator is coming out with their software stack on how to run it.
Right.
And every model was coming out with the software stack on how to run the model. So now all of a sudden you imagine an enterprise that wants to run multi-accelerator, right? And wants to be able to take advantage of innovation at the accelerator level and innovation at the model level. Like they end up with 22 stacks, right? That they have to manage. Right? Because they're all silos. 42. So the mission that we have is like to build one platform. Like what we did with Linux back in the day.
Yeah,
Like
awesome.
to make Linux heterogeneous, right? Because you had this world of dating Unix. But so we're trying to create this world where there's this single platform that can run all models
not becoming Windows.
on all accelerators. Yeah. No, like I think that this community would never let that happen. So that's really the vision, and Kubernetes is the best place because there's so many things. One, because it's a pattern everybody already uses. So what if they can be lazy and bring AI workloads into that world that they already know how to manage? But what it means is there's a lot of leverage of existing Kubernetes capabilities that we need, like to build AI at scale. And they're already there. And and the whole Kubernetes community has been like really gracious to kind of extend and change patterns, K-serve and other things, the gateway, right? To like recognize that AI is an important workload and we need to like add extensions and capabilities to run it. So I think we're off and running. And I think like, is anybody running this? Like some of the largest banks are already now like, getting down this pathway, right, to run these things. So hopefully like, your next, forays, we're talking about user stories. Like that would be like the best part because the capability is ready. So it's really around bringing the users into it and having some user stories of, what they've done with this.
Cool. Thank you very much.
Yeah, thank
Interesting.
you.
A lot of to think about.
Would have to have you back on the podcast in the future.
We'd be happy to.
Yeah.
Okay.
Thanks for having us.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl, via Spotify, Apple en alle andere favoriete podcastproviders.